A supposed comet is catching the attention of some of the nation's most renowned scientists, as one Harvard professor is raising the theory this may actually be a piece of alien technology.
Right now, as you read this, something extraordinary is happening in our solar system. Something that has captured the attention of Harvard's most brilliant minds, NASA's top scientists, and observers around the world. On a clear night in July 2025, astronomers detected something that shouldn't exist, an object moving at impossible speeds, an intruder from another star system. And for the first time in human history, we're watching it unfold in real time. Dr. Sarah Chen stares at her computer screen at Harvard's Center for Astrophysics, her coffee growing cold. The data doesn't make sense. The object, designated 3I/Atlas, is moving at 40 kilometers per second, far too fast to belong to our solar system. This is 3I Atlas, the third confirmed interstellar visitor to enter our solar system. The I stands for interstellar. The number 3 means we've now seen 3 of these cosmic wanderers. But this one is different. This one is heading toward the inner solar system, and it's putting Mars directly in its crosshairs. Unlike the previous visitors, the mysterious cigar-shaped Oumuamua in 2017 and the comet-like Borisov in 2019, 3I Atlas carries something far more terrifying. Scientists have run the calculations hundreds of times. The probability of impact isn't zero. When Harvard and NASA jointly released their preliminary findings, the announcement sent shockwaves through the global scientific community. For the first time, an interstellar object wasn't just passing through, it was potentially on a collision course with a planet we've spent decades exploring. Mars, the red planet that has captured human imagination for centuries. Right now, billions of dollars worth of technology crawl across its surface. NASA's Perseverance rover, still collecting samples after 4 years of operation. The veteran Curiosity rover, marking 13 years of discoveries. Orbiters mapping every detail of the Martian landscape. All of it could be wiped out in seconds. The physics are terrifying. 3I Atlas, estimated to be several hundred meters across, is traveling at speeds that would make it one of the most violent impacts in recorded planetary history. At 40 kilometers per second, the energy release would be equivalent to hundreds of nuclear weapons detonating simultaneously. Mars has been scarred by impacts before. Its surface tells the story of billions of years of cosmic bombardment. But those were local asteroids and comets, born in our own solar system. This is different. This is an alien traveler, forged in the fires of a distant star, carrying the chemical fingerprints of worlds we've never seen. And it's carrying something else, the possibility of life. Dr. Amanda Rodriguez, a planetary chemist at MIT, has been analyzing the spectral data from 3I Atlas around the clock. What she's discovered has implications that extend far beyond a simple impact scenario. The object's composition is unlike anything in our solar system. Exotic isotope ratios, chemical signatures that speak of formation processes near young, violent stars. Elements that suggest it formed in environments where the building blocks of life might exist in forms we've never encountered. If 3I Atlas impacts Mars, it won't just be delivering destruction, it will be delivering alien chemistry directly into Martian soil. For the first time in history, we might have a sample return mission from another star system, but not in the way we planned.
The implications go beyond science. Dr. Michael Torres, a philosopher of science at Oxford, puts it bluntly. We're witnessing the potential contamination of Mars by genuinely alien material. This challenges everything we think we know about planetary protection, about the search for life, about our place in the galaxy. For decades, we've sterilized every spacecraft sent to Mars, desperate to avoid contaminating it with Earth life. Now, the universe itself might be about to contaminate Mars with chemistry from a completely different stellar system. There's nothing we can do to stop it. Observatories across 6 continents are now tracking 3I Atlas continuously. Every measurement refines our understanding of its trajectory. Every data point brings us closer to knowing Mars's fate. The European Southern Observatory in Chile, the Keck telescopes in Hawaii, radio telescopes in Australia. Humanity has never focused such concentrated observation on a single object. We're tracking our potential future disaster in real time. But here's what's keeping scientists awake at night: the uncertainty principle of orbital mechanics. Small measurement errors compound over time. A tiny miscalculation could mean the difference between a near miss and catastrophic impact. Mars isn't just a science project anymore. It's humanity's backup plan. SpaceX is developing technology to transport humans there within the decade. NASA's Artemis program sees Mars as the next great leap. China, India, and the UAE have all announced Mars ambitions. One interstellar intruder could change everything. If 3I catalyst strikes Mars, it could alter the planet's environment in ways we can't predict. The thin atmosphere offers no protection. Dust storms could rage for months. The carefully mapped landing sites for future missions could become unrecognizable. Decades of planning could be erased in an instant. But perhaps the most disturbing realization is this: if it can happen to Mars, it can happen to Earth. 3I Catalyst is a messenger from the cosmic darkness, reminding us that space is not empty. It's filled with wanderers, objects ejected from distant star systems, traveling for millions of years before intersecting with planets like ours. We've been living in an illusion of cosmic safety. Our solar system isn't a closed bubble. It's part of a vast galactic ecosystem where matter routinely exchanges hands between stars. We're not as isolated as we thought. We're not as safe as we believed. If the worst happens, it will also create an unprecedented scientific opportunity. Never before has humanity possessed the technology to observe an interstellar impact in real time. Our Mars infrastructure, orbiters, landers, rovers, would capture every moment of the collision. Seismometers would record the shock waves propagating through the planet. Cameras would capture the plasma fireball. Spectrometers would analyze the chemistry of vaporized alien rock mixing with Martian soil. It would be the most comprehensive planetary impact study in history. As of this moment, 3I Catalyst continues its relentless approach toward the inner solar system. Every hour brings new data, every day brings refined calculations. The margin of error is shrinking, but the uncertainty remains. Right now, Perseverance continues its methodical exploration of Jezero Crater, unaware that its mission could end not by mechanical failure or funding cuts, but by a visitor from another star. Curiosity, the veteran explorer, continues analyzing Martian rocks that might soon be joined by fragments from an alien world.
The 3I/Atlas scenario has forced planetary defense specialists to confront an uncomfortable truth. Their field has been too narrow. Until now, planetary defense meant protecting Earth from objects born in our own solar system, asteroids and comets we could track and potentially deflect. But how do you defend against objects that appear from interstellar space with little warning? How do you deflect something moving at 40 kilometers per second? How do you protect not just Earth, but all the worlds humanity hopes to inhabit? The answer is chilling. You probably can't. Interstellar objects move too fast, carry too much energy, and arrive with too little warning. We're defenseless against the galaxy's random violence. The story has captured global imagination in ways few scientific discoveries ever do. Social media explodes with speculation, concern, and fascination. Mars, already a symbol of human ambition and technological achievement, now represents cosmic vulnerability. Children who grew up dreaming of walking on Mars now face the possibility that an alien visitor might reshape their destination before they get there. The red planet that has inspired science fiction for generations is now starring in a real-life cosmic drama. The 3I Atlas encounter has sparked calls for a new generation of interstellar object detection systems, telescopes designed specifically to spot high-speed visitors from other star systems, early warning networks that could give us years, not months, to prepare. The Vera Rubin Observatory, coming online in 2025, will dramatically increase our ability to detect such objects. But it might not be enough. We need dedicated interstellar object hunters, spacecraft positioned throughout the solar system, constantly scanning for incoming wanderers. Dr. Elena Vasquez, one of the world's leading astrobiologists, sees 3I Atlas as more than a threat. If this object impacts Mars, it could seed the planet with prebiotic chemistry from another star system. We might witness panspermia in action, life's building blocks spreading between worlds. The samples that Perseverance has so carefully collected might suddenly be joined by material that formed around a completely different star. Mars could become a mixing bowl of two stellar systems' chemistry. The implications for understanding life's origins are staggering. The space industry is watching nervously. Companies have invested billions in Mars exploration and future colonization plans. A catastrophic impact could alter not just the planet, but the entire economic case for Mars development. If 3I Atlas delivers valuable interstellar materials to Mars's surface, the planet might suddenly become even more attractive to mining operations. The ultimate irony: destruction that creates opportunity. Every day brings us closer to certainty. Advanced computer models are processing the most precise orbital data in history. Soon, we'll know definitively whether Mars faces its most dramatic transformation in millennia. But here's what we already know for certain. 3I Atlas has changed everything. It has shattered our illusion of cosmic isolation. It has forced us to confront the reality that we live in a dynamic, interconnected galaxy where matter routinely travels between star systems. Perhaps that's the real significance of 3I/Atlas. Not what it might do to Mars, but what it's already done to us. It has reminded us that Earth, Mars, and every world we hope to explore exists in a vast galactic ecosystem. We are not alone in our corner of space. We are part of something much larger, much more dynamic, and much more unpredictable than we ever imagined. Every star in our galaxy has likely launched countless objects into interstellar space, some through violent stellar evolution, others through gravitational interactions in crowded planetary systems. These wanderers travel for millions of years before intersecting with other worlds, carrying with them the chemical fingerprints of distant suns. As we watch 3I/Atlas approach its closest point to Mars, we're witnessing more than a potential collision. We're witnessing the first real-time interstellar interaction that humanity has ever observed. Whether it hits or misses, we're watching cosmic history unfold. Right now, Mars continues its ancient orbit, unaware of the drama surrounding it. Perseverance analyzes another rock sample. Curiosity navigates another Martian slope. The planet that has captivated human imagination for centuries continues its patient existence, while scientists around the world hold their breath. 3I/Atlas carries a message from the galaxy. You are not alone. Your solar system is not isolated. The universe is a dynamic place where worlds influence each other across vast distances. What happened around a distant star millions of years ago is now approaching your cosmic neighborhood. This is what it means to be a spacefaring species. We're not just exploring our local neighborhood anymore. We're beginning to understand that we're part of a vast galactic community, connected by the wandering messengers that travel between the stars. The observations continue. The calculations are refined. The uncertainty slowly resolves into certainty. But regardless of the outcome, 3I/Atlas has already achieved something unprecedented. It has connected us directly to the larger galaxy. For the first time in human history, we're not just looking at distant stars and wondering what's out there. We're watching something from out there approach our own backyard. We're no longer passive observers of the cosmos. We're active participants in galactic dynamics. The age of interstellar awareness has begun. From now on, humanity will watch the skies not just for threats from our own solar system, but for visitors from distant stars. We'll scan for the wanderers, the refugees, the messengers from other worlds, because 3I/Atlas won't be the last. Our galaxy is filled with such objects, traveling ancient paths between the stars. Some carry the potential for destruction. Others might carry the seeds of life itself. All of them carry stories from worlds we've never seen. As we wait to learn Mars's fate, we've already learned something profound about our own. We live in a galaxy where worlds influence each other across vast distances, where the past actions of distant stars affect the present of our planetary neighbors, where alien chemistry can arrive unannounced and uninvited. This is the new cosmic reality that 3I/Atlas has revealed. We are not isolated. We are not alone. We are part of a vast, dynamic, and gloriously unpredictable. The question is not whether Mars will be struck by an interstellar visitor, but how we'll prepare for all the other visitors that are surely coming. The universe is calling, and it's not just asking if anyone is listening, it's asking if anyone is ready. 3I/Atlas continues its journey through our solar system. Scientists worldwide maintain constant observation. The next interstellar visitor could arrive at any time. Are we watching?